Welcome to The Explainer. Today, we're taking a look under the hood of Claude Code, a developer tool that's gotten so good it actually writes about 90% of its own code. We're going to break down how on earth they built it and what it signals for the future of engineering itself.
All right, so here's our game plan. We'll kick things off with some numbers that are just staggering. Then we'll see how this whole thing started from a total accident, understand the core philosophy behind it, watch how fast they can build with it, and finally think about what this means for all of us.
So, first things first, let's just set the stage for why this story is such a big deal. And honestly, the best way to do that is to just look at the metrics, because they are pretty jaw-dropping. Get this. Since it launched publicly in May, Claude Code is already on a path to hit $500 million in annual revenue. For any product, that kind of growth is just absolutely wild.
And it's not just the money. The adoption rate is through the roof. We're talking a tenfold increase in usage in just the first 3 months. Developers are jumping on this thing like crazy.
But here's the stat that really got my attention. It comes from inside Anthropic itself. So they doubled their engineering team. Now, normally when you do that, individual productivity takes a nosedive, right? Not here. The opposite happened. Their output per engineer actually shot up by 67%. Why? Because they were using their own tool to build and it was working like a charm. So how in the world did a tool this powerful even get started? Well, like a lot of revolutionary ideas, it didn't begin with some grand strategic plan. It actually started as a simple, kind of playful experiment. You've got one of the founding engineers, Boris Cherny, and he's just tinkering with the Claude API. He builds this little command line tool, hooks it up to AppleScript so he can ask it what song is playing. Fun, right? But then he gives it a new superpower, the ability to read and write files on his computer. And that's when everything changed. He just sat back and watched as the AI started exploring their entire codebase, all by itself. It would read a file, see the import statements at the top, and just decide to go and read those other files to get more context. This is the wild part. He never programmed it to do that. It was a completely emergent behavior. The AI just figured it out. And that incredible moment led the team to this core idea they now call product overhang. The basic concept is that these AI models are often way more powerful than we think. Their true potential is just sitting there, hanging over our heads, waiting for us to build the right interface to finally unlock it. So this product overhang idea wasn't just some cool insight they had one afternoon. No, it became the absolute bedrock, the driving philosophy for how they designed and built all of Claude Code. This led them to a really simple but powerful mission. Don't build a bunch of complicated features on top of the AI. Instead, the goal is to build the thinnest, most lightweight shell around it. Just get out of the way and let the raw intelligence of the model shine through. This philosophy even dictated the technology they used to build the tool itself. They made a very deliberate choice to use super common stuff like TypeScript and React. Now, why would they do that? Because the Claude model was already a world-class expert in those languages. It's what they call an on-distribution choice. Basically, why teach the AI a new trick when it's already a grandmaster at the classics? And the payoff from that decision is, frankly, just bananas. Because the tool is so fluent in its own codebase, it now writes 90% of its own new code. Think about that for a second. It's a self-improving system literally building the next version of itself. Okay, so what does it actually feel like to work this way? What does your day look like when you have a tool that writes 90% of the code for you? The answer is just one word: speed. A kind of development speed that's almost hard to comprehend. Let's look at a real-world example. They needed to build a simple to-do list feature. One engineer spun up over 20 different fully working prototypes in just a couple of days. Let's take a quick look at that journey. So he starts with the most obvious thing you could do, right? Just a simple text list that shows up in the terminal after you run a command. It works, but it's not exactly elegant. Okay, so a few versions later, he tries something different. He turns it into this interactive pill that sits at the bottom of the screen, kind of like a background task that you can pull up to check on the progress. Still not quite there. So next up, he experiments with a completely different UI. This time, it's a drawer that animates and slides in from the side of the screen. Pretty slick. And after trying out a ton of other ideas, he finally landed on the shipped version, integrating the tasks right into the main thinking spinner so you can't miss it. The amazing part is that this whole process, from a vague idea to a polished, shipped feature, happened at a speed that would have been impossible before.
Now, this story of rapid prototyping isn't just about one team building one cool feature. This is a preview, a glimpse into a fundamental change in how we might all be building software very, very soon.
What we're seeing is the emergence of a new AI-first workflow. In this world, the speed of iteration becomes the only metric that matters. Prototyping shrinks from weeks or days down to mere hours. And the role of the engineer, it starts to change. You're less of a line-by-line coder and more of a guide, a prompter, a curator of the incredible work the AI is producing. And all of this leaves us with one last massive and maybe a little provocative question to chew on. In a world where your tools can build 90% of themselves, where the AI is doing the vast majority of the heavy lifting, what is the new role for the human engineer? What do we build next?